Hello everyone. In this session, we are going to discuss about a round robin scheduling algorithm. So this is also working the concept of the first come first serve, but the difference is we are just switching the each and every process based on some time slice. So we are just setting the common time for the each and every process. Within the time limit, the process has to complete. So the remaining execution time is there in the sense the process need to go and stand in a line again when the chance is coming, so he need to execute. So equally we are just dividing the time slots for the all the process. For example, if the DTP, the printer, only one printer is available, so all the 60 students need to take some printouts. In the sense, to avoid the conflict, they are just giving the permission only exactly 5 minutes for one person. So like that they are allotting. So the person one, it's coming at the 9 o'clock. He need to work with only 2 minutes now. He can complete and then leave it. At the 9 to the next person will come from the 9 to and then 9-7. So the 5 minutes only allotted for the person 2, but he needs to work with the 15 minutes now. That 5 minutes only he can able to take the printout. After that he need to leave the printer to the next person. So again the person 2 will go and stand in a line. So now he need to go and stand in the end of the line. So once all the persons are completed in front of the P2, then only he will get a chance. So like that the time is going to be equally sliced for all the process. So here the ready queue will be acting as a circular queue. So each and every person's, once it's completed, again he will go and stand in a line. Again he will come. Once his job is over, he will left the queue. Unless otherwise he will go and stand in a line. So this process will be continuing. So the same example we are just taking what we solved in as a first come first serve. So after finishing that, we can able to see what is the difference between the first come first serve and then round robin. So here the time quantum will be allotted by basically the length will be decided by 10 to 100 milliseconds length. So now according to this example, we will just take the quantum time 4. For this example, I am just taking the time quantum or slice or quantum time, whatever it is. So I am just taking as a 4 millisecond. So now I'll start with the working of Gantt chart. So all the process arrived at the time of 0. Everyone is standing in a ready queue. So the time of 0, P1 will start. The quantum time 4, only 4 milliseconds it will work. It will preempt the process and it will go and stand in a line. So totally 20. So 4 it's complete. So remaining 20. So next P2 will come. So the P2 burst time is only 3. Even though we allotted the 4, it will complete its job within a 3 milliseconds. So it is leave the process at the time of 7. It is completed. Again P3 is coming. So P3 also the burst time is 3. So at the time of 10 it will complete. So now in a ready queue, so only one process is there. Every 4 minutes the P1 process it will be switching, because in a ready queue we don't know how many processes are standing in a line. So every 4 milliseconds the P1 is going to be preempt, and then we are checking the ready queue. So no other process, again we are just giving the chances to the P1. So like that the every quantum time 4 milliseconds or 5 milliseconds it will be stop, and then we are just check with the ready queue, and then the process are going to be added here. So now again P1 will start. It will execute the 4 millisecond. So already 20. So remaining 16. So like that it will continue. Again the P1, 14. P1 4 milliseconds it will execute. So 18. Now the 4 will reduce 12. So like that it will be go on. So P1 it will complete its job as 22. and then again it will execute P1. Execution time is 26, then P1 and 30. So at the time of 30, the P1 is going to be in, even though no other process is there. So as per this example, we know P2, P3 are completed, only P1 is standing in a line. But the CPU scheduler doesn't aware of that. So every 4 milliseconds, the P1 process will preempt, and when go and check the ready queue, then only it is going to be allotted. So this is the one of the drawback of or disadvantages of the round robin algorithm. So the keep on swapping and swap out process will be happen. So based on its quantum time. If the quantum time is too minimum, so for example 1 or 2, now every 1 or 2 milliseconds the swap and swap out process will will work on. So obviously the time wastages. And then if you are just checking them waiting time, so now you're just calculating the waiting time when it is completed. So the P1 waiting time, so this is a working time for the P1, again this is a working time, so only this period is a waiting time for the P1. So 10 minus 4, it's a 6 is the waiting time. For the P2 waiting time 4, P3 waiting time 7. So totally if you are just taking the average waiting time around 5.6. So overall the average waiting time which will be increasing for the round robin algorithm. So similarly the turnaround time also is going to be increasing because it will be maintaining the equal time slice for the all the process. So sometimes even a large number of the burst times, so that having the highest priority keep on it needs to be wait. So this is the disadvantages of this round robin scheduling algorithm. Thank you so much.